Assalamualaikum and good morning to Dr. Arniza. I am Nur Adriana and the topic that I chose to talk about is circularity in the craft pulp production from sugarcane baguette. Besides paper, sugarcane can be transferred into various products such as sugar. Sugar making process starts when harvested sugarcane is chopped into lengths and conveyed rapidly to the processing plant. At the mill station, the cane is mechanically unloaded, placed in a large pile and cleaned prior to milling. Then cane is extracted step by step in successive mills with adding imbibition water for complete extraction. The crushed cane exiting the last mill is called bagasse, which will be further used as the main component for pulp production. The raw juice from the mills is strained to remove large particles. It is then clarified with lime and heated to inactive the enzymes. A heavy precipitate called mud is separated from the juice in the clarifier by centrifuge. The clarified juice, called as the light juice, then passes through heat exchangers to preheat prior to evaporation. Evaporation consists of two stages: concentrating the juice in an evaporation station, continued by crystallizing the sugar in vacuum pans. Crystallization produces sugar crystals which will be washed by water. The washed water centrifuged from the crystals, molasses, is a byproduct of this process. Molasses is then used as an animal feed supplement and as a substrate for fermentation processes. Sugar crystals which were separated from the molasses were dried in fluidized bed and transferred into packing bins to be sent to bulk storage. Alkaline pretreatment has been chosen as the pretreatment process for sugarcane bagasse. Alkaline pretreatment has received a lot of attention lately because it can remove the lignin from biomass, thus improving the reactivity of the remaining polysaccharides and removing acetyl groups and various uronic acid substitutions on hemicellulose. The mechanism of alkaline hydrolysis is saponification of intermolecular ester bonds, cross-linking silane hemicelluloses and other components. Dilute sodium hydroxide treatment of lignocellulosic material causes swelling, leading to an increase of internal surface area, decrease in the degree of polymerization, a decrease in the crystallinity, separation of structural linkages between lignin and carbohydrates, and disruptions of the lignin structure. In the process of wood delignification, alkaline treatment results in a residue called black. Craft pulping has been chosen as the pulp production method. Craft pulping begins with digestion. In the digestion process, the fibrous materials is broken down into individual pulp fibers, which are the sclerenchyma cells in the case of bagasse. For bagasse chemical pulp, the bagasse is normally loaded into a twin-screw horizontal digester and the fibers are exposed to chemicals at elevated temperature and pressure. The wet bagasse is conveyed from the stockpile over a metering system and fed to the screw feeder. This removes excess water and creates a plug of bagasse which allows feeding of the bagasse into the pressurized reactor. Steam and cooking liquor are subsequently injected. A blowback valve may be installed on the inlet chamber when inadequate bagasse is meted to the digester. The second process is production of black liquor. Similar to most agricultural residues, there is a high amount of silica present in bagasse compared to wood chips, and the amount varies widely. The quantity depends on a range of agricultural factors such as manual or mechanical harvesting, soil and cane type, as well as climate. It is desirable to remove the silica, otherwise there will be excessive equipment wear and it causes problems when concentrating the black liquor. The approaches to removing silica are generally to remove silica from the raw material, remove silica from the black liquor, or remove silica from the green liquor. Another approach is to install an extra black liquor evaporator so that one can always be offline for cleaning, mitigating the need for silica removal. The strategy employed reflects the extent of the problem. Craft pulping is continued by the bleaching process. Pulp bleaching occurs by adding chemicals to the pulp, possibly in the presence of the gas or small amount of a secondary chemical, whereby the chemicals react with the pulp to increase its brightness. The pulp is then washed to recover the chemicals and pressed to reduce the moisture content. The table shows the bleaching sequences starting from chlorination, alkaline extraction, followed by the addition of hypochlorite, chlorine dioxide, peroxide, oxygen, chelating agent, and ends with the reaction with ozone. This sequence of chemical addition, reaction, washing, and pressing typically occurs 3 to 5 times. Craft pulping ends with the paper making process. The formation of a fiber mat is a filtration process whereby a suspension of fibers are deposited one layer at a time and water drains through the formed mat. The result is that the flexible fibers overlay one another, forming a sheet of paper. The two main types of paper formers processing pulp into paper products are the traditional Fourdrinier formers and twin wire formers. Pulp fibers are suspended in water at 0.1 to 1% before being sprayed onto the moving fabric, which operates at speeds from 50 to 2000 meters per minute depending on the product being made. Following paper formation, most of the water is drained from the fibers and the moist wet sheet is mechanically pressed, dried and reeled. Once a continuous dried paper sheet is produced, it is slit, cut and packaged ready for distribution. Sustainability of the pulp production design. The pulp production design reduces environmental impacts along every step in the life cycle of a product. This includes minimizing non-renewable energy consumption and waste, enhanced operational and maintenance practices. Products are also environmentally preferable products. Non-wood fibers grow faster than trees, require less water and pesticides, and can be produced sustainably. By using renewable and sustainable materials, the paper industry can reduce its reliance on non-renewable resources, conserve natural resources, and reduce waste, making it more sustainable and environmentally friendly.